In this question, it is given that a hollow metal cube with side 0.5 meter and wall thickness of 5 into 10 raised to minus 3 is filled with ice. It is immersed in water, so we can just consider that this is immersed in water at a water tank maintained at a temperature of 100. So you can write this is ice at 0 degrees Celsius and outside it is water at 100 degrees Celsius. There will be a flow of heat energy from this water towards ice. So this ice will start melting. So hollow metal cube with a side of 0.1 meter. So we can just 0.5 meter. So we can take it as its length of this one is 0.5 meter. And wall thickness, the thickness of wall is given, that is equal to 5 into 10 raised to minus 3 is filled with ice. It is immersed in water tank maintained at 100 degrees Celsius. And our aim is to find out the amount of heat melted in 335 seconds. And the conductivity of metal is given, and latent heat of fusion of ice is also given. So we can use this equation. dq divided by dt is equal to Ka delta T divided by L, because heat is going to conduct through the walls of that container. So we can write the value of this dq is the amount of heat energy, which is q, and take it as is happening, it is flowing for a time t second, is equal to k into, and we know that for a cube there are 6 faces are there. So if area of one face is a, so total surface area will be 6 into a into the delta t. So these are the total cross-sectional area through which the heat is flowing, into delta t, which is the difference in temperature, which we can take it as 100 divided by length, which is equal to the thickness of this arrangement. So this q can be written as nothing but the mass into latent heat. So if you are supplying q amount of heat energy, by which m amount of water is converted into ice is converted into water. So the value of q we can take it as m into L, latent heat of fusion, divided by time is equal to, we can take it as its thermal conductivity, area of one phase, into 600 divided by thickness L. So Rm is to find out the value of m, so we can write as Ka into 600 into time divided by latent heat and the thickness L. Now we can substitute the values. The value of K is nothing but conductivity, which is given as 0.5 in a size system, and the length of one side is given as nothing but 0.5 meter. So the area we can take it as L square, which is 0.5 into 0.5, that is 0.25 into, we can write 600 into the time taken, which is given as nothing but 335 second, divided by the value of latent heat, which is given as nothing but 335 into 10 raised to 3 joules per kilogram, into the value of thickness, which is given as nothing but 5 into 10 raised to minus 3. So you can find out the value of m over here. So I'll get the answer as nothing but 15 kilogram.